We are demonstrating here Qualcomm Snapdragon X50 modem. This is the first Qualcomm 5G modem capable of doing millimeter wave call. We are demonstrating here millimeter wave call on 28 gigahertz on a Qualcomm reference platform, which is also running at 800 megahertz carriers. Each carrier is a 2x2 MIMO, and we are achieving close to 4 gigabits per second in this live demo. So as you can see that we are able to hand obstruct the device and we are still able to maintain the link. And also if we rotate the device across both azimuth and elevation, and you are able to maintain the link. This demonstrates that Qualcomm's millimeter wave technology is able to beamform and is able to maintain the link in an over-the-air environment. Qualcomm's Snapdragon X50 modem is planned to be available in smartphone devices in first half of 2019. And the carrier trials are expected to happen at the later part of 2018.
At MWC, we're showing our simulation platform where we work with operators in 2 major cities to show what real-world performance would be like once we overlay 5G NR on an existing LTE network. So we, based off of extensive over-the-air testing and RF modeling and even high-definition maps where we can see buildings and foliage and trees, to really get a sense of what 5G is going to look like as we start to deploy it in these cities in the next year or so. One of the things that we're seeing in the network is, on the network side, is huge capacity gain. So nearly 5x capacity gain across 11 to 13 cell sites in each of these cities. But it's not just about network capacity gains. We're also able to drill into actual user experience that these users are getting on their devices. So we modeled 3 different traffic models. Video, so video streaming, so streaming an 8K video to either your mobile device or your virtual reality headset, as well as downloading a 3 gigabyte movie, and then browsing, so typical web browsing, Facebook and streaming type of applications. And what we see is tremendous improvement in user experience. So with the 5G NR devices, 100% of the time we're operating at that peak video resolution of 8K, 120 frames per second, even in the worst cell conditions. Even at 10th percentile, low signal quality, we're getting that full video resolution. We didn't just model throughput performance, but we also looked at latency. So one of the things that 5G is going to deliver is significantly better latency that's going to allow us to do real-time applications. So we're talking about interactive video conference calls, interactive virtual reality, augmented reality, but even getting into new applications and new use cases like controlling an autonomous vehicle or controlling a factory. And so what we were able to model in the tool is seeing 50th percentile down to 5 milliseconds of latency, beyond even human perception of what you can perceive in real-time performance with 5G.